Good afternoon to all of you. I'm Frédéric Kaplan. I'm the president of the Time Machine organization. It's really a pleasure to be with you for this virtual conference. I'm going to speak a bit about the Time Machine. It's a scientific adventure that started several years ago and which is continuing for the year to come with a very exciting ambition, which is to build the first 4D mirror world. Let me maybe illustrate the idea with a particular example. You see this image of Venice. It represents Venice in 1808. It may look like a normal 3D render of a virtual world, but there's one big difference, is that that model has been entirely generated in an automatic manner based on historical record. What you see here is not one artist, which has come and made some modeling of each of the pieces. It's a fully procedural process which starts from historical data and try as much as it can to reconstruct a reality of the past, or at least a possible reality of the past. So how does it work? Well, you have here one of the most precious assets for us, which is this historical cadaster. It's called the Napoleonic cadaster. It was built in Venice and designed in Venice by the French administration in 1808. And it actually represents exactly the state of the city, both from a geometrical point of view, but also describing all the inhabitants of the city at that particular moment. And the thing which is interesting is that for several years, we've been designing algorithms which are capable of extracting directly information from this cadaster. The idea is that you have now machine vision algorithms which are capable of not only decomposing, segmenting the image in the various parcels, but also understanding their geometry and possibly also reading the different numbers you are seeing in these various parcels. And that permits to get a form of automatic map of Venice in the 1808 and to connect that map to other databases. I mean, in that moment, that were registered with registers with various names of people which were living in the various places. So in one shot, you get a full representation of the city. And this is how, through various research, we've been, by combining this different historical information, capable of progressively getting a form of information skeleton, which is describing for each parcel of the city the evolution of the cityscape. Having some particular event like fires, having some particular event like destruction, reconstructions, and playing like a gigantic four-dimensional film, which is summing up all the information we have about the city evolution in time. So this is, of course, not a definitive database. It is a continuously evolving database. It's something which is revised by historians, which is confronted with new historical data, but that serves as a kind of skeleton in which you can on which you can attack various type of information. So how does it look? For instance, there's here an interface which permits to compare the document on the right here, the Napoleonic cadaster, and the basic extrusion which is made out of this cadaster. And you can change here with a slider the date in time, compare with different other type of sources, here the satellite imagery, and see how the map is actually adapted to that particular setting. The thing which is interesting is that, of course, all these technologies are extremely generic, and they can be used at different scales with different type of sources. And one of the idea of Time Machine is precisely to scale up in that direction. Here, of course, you get only part of the information, which are the geometric information at a given moment. It's very important that you combine this with all the visual evidence that are existing concerning that particular places. And here again, you end up with a possibility for machine to help us in that task, actually by clustering automatically the hundreds of thousands of images there are about Venice in various small clusters, which are corresponding to the different places. So some are describing very famous landscapes and very famous views of the city. But others, of course, are dealing with particular, maybe lesser known elements. And so you end up progressively accumulating this visual evidence, and you will have to connect this visual evidence on the one hand with the 2D geometry of the city and the corresponding extraction, but also with the 3D remaining elements which are currently present in Venice. And for doing this, one challenge is, of course, to be capable of building a very large scale 3D model of the city. But one maybe even more difficult challenge is to be capable to store them and accumulate progressively in space and time a very dense representation in terms of cloud points of a city like Venice. And what you have in that particular video is a demonstration of the time machine server, which actually has this possibility of working, like tiles, but it's not 2D tiles, it's 3D tiles or 4D tiles, even if we want to include the time dimension, and it's loading information on 3D models which are corresponding to the different scale in which you are looking at a given moment. So here we are moving from a very large view of the entire country of Italy and zooming here a drone-based model, which is good at a given resolution, but as you're scaling up on one particular part of the city, you have to load another model, which is, in a case like this one, a model which was done with photogrammetry directly on a particular place in Venice, San Giacomo Square here. So the possibility of scaling down, from the very big representation of city to the very small representation of city is extremely interesting because it permits really to progressively build and densify a model of the present reality. And the key idea when you reach that element is to be capable of linking everything together. So here, I'm showing you an example where we start from a model of 2016 of the city of Venice. We move from photos directly concerning these images. Then we are progressively adjusting to the cloud point. The cloud point is also aligned with ancient representation of the city, which is aligned with different 3D model which were made based on the hypothetical idea, which is aligned always with the 3D model of the present, which is aligned with the model of the 1808 Napoleonic cadastres. And using various other techniques, we can then link the information you have, for instance, in parcel 9006 with the name of Francesco Raspi. Here again, these are names which are automatically deciphered by handwritten recognition, and linking that particular Francesco Raspi with another Francesco Raspi, which happened to live in Venice in 1740. In 1740, we have another model, which is slightly less precise, but like a giant Sudoku progressively. These different views of the city are connected with one another and progressively densify the representation of the past we may have of a city. So this is the general idea shown on one example. It's the idea of the mirror world, the idea that you have now for each city a model, which is a 3D model, a kind of double of that particular city. That model, as any computer science model, is tagged, attached with various types of information. It's not just a static model, but more importantly for us, that model is a 4D model. That means that you don't just have the current state of the city. In fact, that has no sense to have the current state of the city because the city is always evolving in the future and has been evolving from various states in the past. And so you build a single model which is connecting both this historical information with also the information that will happen in the future concerning the city. And that particular 4D model is what we call a local time machine. A local time machine is a group of entrepreneurs, academics, people working in the political areas, which are deciding to join together to densify the past of a particular city and building a model like this one. And what the Time Machine organization do is try to help each of these local projects to benefit from all the progress which are made across Europe and across the world, and very fastly also to circulate all the evolution which are made in each of the local time machine. So it's a way of sharing information. It's a way of sort of standardizing the tools so that progressively a tool which was made in Venice, in Amsterdam, in Antwerp, in Paris can be used in another city when they start actually to work on a particular model. So the time machine organization is structured in a way which permits also for the local time machine to make a more rapid connection with the various applications. That can be done if you have such a 4D model. I mean, of course, for scholars that want to study the city, but also for city planners, also, of course, for all the creative industries, games, for instance, but not only, also tourism. And all the future imaginative ideas we may have on how to deal with that particular mirror world. The time machine is regrouping also all the research which is currently done at European scale for scanning more efficiently, for using various artificial intelligence technique to be more efficient, for extracting information, and for experiencing information in an immersive way through the various way we're going to relate with these 4D world informations. You can go on timemachine.eu. We'll see in real time the various projects which are popping up, focusing on small aspects of each of this bigger problem, but actually progressively densifying city by city all the information we have concerning that particular city. It's the idea of the mirror world, which was described by Kevin Kelly 2 years ago, essentially. I mean, it's an important idea. The idea that we had different type of platforms. The web was the first one. The social media may have been the second one, but actually the third platform is something which is completely transforming our future relation to information. The mirror world is something as important as was the web, or as were important the social media. And maybe one hope is that that third platform will be, this time, maybe a European one. So if you want more information, don't hesitate to actually go on timemachine.eu, and it's a pleasure for me to interact with you about this project. All the best. Bye-bye.